So, hi everyone. Hi everyone. Please confirm if the audio is coming fine or not. And I see that there are only two people in the chat right now. So, okay, audio is good. That's nice. So, let's start the session. Second. Okay, nice. So, let's start with the very first problem. The problem says that we have to find out the original type string. This is the very first part of the problem. Um, this problem has a follow-up. It came as the fourth problem. So this is the easier version. The problem says that, let me do one thing. Yeah, let me just copy paste it here. Nice. So the problem says that Alice is attempting to type a string on her computer. However, she tends to be clumsy and may press a key for too long, which results in a character being typed multiple times. So it is like if I have to write Raghav, and let's say I press the key A for too long by mistake, and the word is typed like this. Like A is typed multiple times instead of being typed once. This thing can happen. Although Alice tried to focus on her typing, she is aware that she may still have done this at most once. So if I'm talking about writing Raghav, then I know that I might have done this at most once, which means that any specific character might be occurring more than once, but it won't happen like this, where you're having more than one character being repeated, like this V is being repeated more than once. Similarly for A, this thing won't happen. At most, one of the characters would have been typed multiple times. So we are being given a word, and this represents the final output, which is being displayed on LS screen. So we have to return the total number of possible original strings that LS might have intended to type. So let's say this is the final output string ABBCCCC. So if the final output string is ABBCCCC, then what could have happened? First of all, please tell me whether this problem statement made sense or not. Or maybe even if it didn't make sense, it would make sense after looking at the example. So in this example, we have a word ABBCCCC, and we know that there might be some character which is typed more than once. So the possible strings which Alice could have been trying to type are ABCCCC. Let's say if Alice wanted to type this, and instead of typing B once, she typed it more than once, then the string would be formed. Similarly, there can be a string like ABBC. Alice might have wanted to type this and hold C for quite some time, and it got there four times. Similarly, it could be ABBCC and ABBCCC, and it can obviously be ABBCCCC, which is the original string. There is a chance that Alice didn't make any mistake at any place. So this is also possible. And these are the four strings which she could have intended, um, and might have reached here. So these are the possibilities where she made some mistake. So this is the example, and yeah, they have shown the exact five strings. Similarly, they have given some more examples, like if she wanted to type type A, B, C, D. We know that none of the characters is repeating more than once. All of the characters are occurring only once. So obviously she didn't make any mistake, because if she had made some mistake, then the character would have been coming up more than once. And in the string A, if there is a string like A, then what are the possible strings which Alice could have tried to type? Maybe she wanted to type A itself. है ना? Maybe she wanted to type A, like triple A, and at the place of one of those A, she might have mistakenly typed it more than once, and this could be an extra A. So with this possibility, she could have wanted to type triple A. Similarly, she might have typed two A's by mistake, or she might have typed three A's by mistake. है ना? So these are the four possible strings. The same logic goes in the previous example as well, that she might have typed one extra B by mistake, or she might have typed one extra C by mistake, or two extra C's by mistake, or three extra C's by mistake. Is it possible that she typed four C's by mistake? Yes or no? Is it possible that the string she wanted to type was ABB, and by mistake she typed ABBCCCC? Obviously no, because we know that instead of one of the characters, it might be repeated. है ना? But it is not possible that she did not want to type C and typed it four times by mistake. So I hope the problem is clear. In the problem, we just have to tell the number of possible substrings. So in this case, we have five possible strings. So the answer would be five. The answer here would be five. In this case, we have four possible strings. So the answer would be four. Okay, so some people have written no. Is this no for having no doubts, or is this no for not being able to understand the problem statement? I just forgot what did I ask in chat. So if you have some doubt, then please write doubt in chat. Otherwise, say move on. Like we should move on to thinking about the logic part of the code. Okay, so you wrote no for saying that you don't have any doubt. Okay, very well. Let me read the other chat as well. I was scared after seeing the second and third question, so I quit after doing the first. Okay. Let's move on to the like logic part. What we have understood right now is we know about the final output, and the strings which she could have intended to write will just miss out some of the characters. Like it might miss out a C, or it might miss out two C's, or it might miss out three C's, or it might miss out a B. And we know one more thing, since she made at most one mistake, this is not possible that she wrote an extra B by mistake and an extra C by mistake. This won't happen. Only one of the characters would be written extra times by mistake. So if we have a string like A, B, 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 C, 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 D, D, E, let's say something like this, then in that case, can I say that if Alice made some mistake among these characters, if she wrote A by mistake extra times, then all of these would remain the same. है ना? In the string which she wanted to write, all of these would have been same. Only this part would have been faulty. Or if she would have written some B's by mistake, then only these would be different. This part and this part would have been the same with the string that she wanted to write. है ना? Similarly for this or this or this. In a nutshell, what I want to say is, I can say either she wrote some A's, extra A's by mistake, or she wrote some extra B by mistake, or she wrote some extra C by mistake, or some D or some E. है ना? And one more thing. if the string is something like AABBBAA, is it possible that she wrote this A and this A by mistake? Like she typed the character A more than once by mistake at two different places? The answer is no. Like Alas made that mistake at most one place. Basically, while typing a character, she typed it multiple times. So that would have happened at the same place now. It won't happen like I by mistake held A for too long at this place and it got uh, like it got typed here as well by mistake. It won't happen like this. So here in this case, we would know that the mistake is either at this place or among these or among these. Is it making sense? Can I consider that all of these are independent of each other? If I make a mistake here, whatever number of extra strings which would have been possible, like uh, Elias might have intended to write only one of the A's, it won't affect whatever different strings could have been generated from here. Yes or no? Is it making some sense? Okay, let's assume that if it then makes some sense. Um, like, let's see if it would make. I don't see any no's right now. Let me take some example. Maybe let's take this example itself. A double B and four C's. So here, according to the logic where we have been going up, either she could have made some mistake while writing this. Let's call these as blocks. Wherever you see consecutive characters, let's call them as blocks. So here are three blocks: a block of a block of BB, and a block of CCCC. So if LS had made some mistake while writing this, then you would have got, like, you could not make any mistake here since you have written only one character. So there is definitely no mistake here. Since this character is coming up twice, and it means that if she had made some mistake, then the string which she would have intended to type would have at least one B removed from it. So the string could have been A, B, and four C's. And in this case, where we have four C's together, you see either she wanted to type three C's or two C's or one C or all the fours. So depending on that, you will have ABBC or A double B double C or A double B triple C. So I just have to count this. Like there is this possible string coming up from because of this block if a mistake was being done here, or these are three possible strings which she could have intended if a mistake was done in this block, or the intended string could have been the final output, maybe if she didn't make any mistake. So you might be able to notice it that if there was one character, there was no possible string which she could have intended and by mistake wrote this. If there were two characters, then you got one string. If there were four characters, you got three strings. So if there is a block, basically if there are m consecutive characters like C coming up m times, then there will be m minus 1 possibilities for how many C's she could have intended to type here, right? So can I say that if I had this kind of a string where I had double A, triple B, let's say four C's and AAA, then the possible strings would be, first of all, I will divide them into blocks: a block of two, a block of three, a block of four, a block of three. So this is a block of two size. There will be one extra string, one possible mistake. There will be two possible strings where she would have made some mistake, three possible strings here and two possible strings here. Adding them up will give me 8 here, and there is a possibility that she intended to type this string itself. So 8 plus 1, you will get 9. So right now, is it making some sense? or is it not making sense? If you have any doubt, then please ask me. I will try my best to resolve that doubt. Okay, nice. So let's move on to the code. The code is pretty simple. Since this is an easy problem, you can even code it in big O of n square. That, like, actually you don't really need big O of n square. Big O of n is fine. Like, even for beginners, I think big O of n should be fine. What you need to do is you will have a string. You have a string. All you want to do is just find out these consecutive characters, the number of consecutive characters coming up together, and then you will find out that thing again and again. I know. So you can just iterate over it from left to right. Let's say this, your I is at this place initially. Keep it here and have another for loop for j. Like, j will go one by one. Let's say if the string was something like uh, a coming up 5 times and then a b. So you can have first for loop for I and then another for loop for j. It will move forward as long as the word of I is equal to word of j. And as soon as you find out any character which is different from I, or maybe j became equal to n j, basically you reach the end of the string. In that case, you will just stop, and you know that the number of consecutive characters you would have found, like the number of times you would have found a consecutive characters, you would have said j plus plus. So j minus I will give you the number of consecutive characters, and then you can just say I equal to j. Basically, you would like to shift your I to this place and again repeat the same process. You know, and that's it. So you would like to increase your answer by j minus I minus 1, because if there are 5 consecutive characters, then the possibilities are you might have wanted to write a or aa or aaa or aaaa. You know, so that's what we are doing in the code. And I initialized with the answer with 1 because we have to consider that what if she didn't make any mistake. And there are these, like, first for loop for I, and then another, instead of running a for loop I ran a while loop for j, and the number of characters in that block is j minus I incremented answer with len minus 1, basically j minus I minus 1. And here I am setting I equal to j minus 1 because I would have I plus plus as well in the for loop. If I was having a while loop, or if I didn't have this, then I would have definitely set I equal to j. But this is just my personal preference to write like this. So is it clear? Should we move on? Should we move on to the next problem? The time here is just big O of n, because we are having a for loop of I side n iterations here. In case if you make some iterations within this while loop, you are incrementing j and then you are setting up I equal to j minus 1. So in a nutshell, you will have only n iterations in total, considering both the for loops, for and while loop. And the space complexity here is just big O of n, the auxiliary space complexity, because we have created only int and these variables only. Okay, so I think we can move on to this next problem now. Great. Okay, so somebody is asking why two for loops. The reason we are applying two for loops here is you're having the first pointer I, at the first occurrence of the character in the block, and then you're running up another for loop for finding out the last occurrence. Either you can think of it in this way, or some people might have actually just have one for loop, and they could have maintained a variable like counter, or you can actually do it with one for loop as well. It's up to you in which way you want to type. I think using two for loops is a lot simpler. Okay, so let's move on to the second problem then. The second problem says we have to find subtree sizes. Yeah, the second problem name is find subtree sizes after changes. The problem says that we have been given a tree rooted at node 0 that consists of n nodes numbered from 0 to n minus 1. The tree is represented by an array parent of size n, where parent I is the parent of node i's, and basically they are just telling the way in which they have given us a tree. And we are also given a string s, where si is the character assigned to the node I, and we have been, yeah, we have to make the following changes on the tree one time, and all of this has to be made simultaneously for all the nodes. So for every node we have to find out the closest node y to node x, such that y is an ancestor of x and sx equal to sy. If y does not exist, then do nothing. Otherwise, remove the edge between x and its current parent, and make the node y its new parent by adding an edge between them. We have to return answer of size n, where answer I is the size of the subtree rooted at node I in the final tree. So let's take this example. This. Okay, very well. So in this example, we are being given this parent array -1 0 0 1 1 1. So for the node 0, there is no parent, that is why -1. For the node 1 and 2, they have node 0 as the parent, and for the other three nodes, they have 1 as the parent. You can see it here. The characters A B A B C A B A A B C is like this: A for the node 0, B for the node 1, A for the node 2, then next A for the node 3, then B for the node 4, and C for the node 5. And initially the tree is looking like this. We can just create an adjacency list maybe, or it might not be required, but for simplicity you can even create an adjacency list and create a tree like this one. After that, what we have to do is, for each and every node, check if there is any ancestor of that node which is having the same character assigned, like in this case. So in this case, the node 3 is having the node 0 with the same ancestor. Like 0 is a node which is an ancestor for 3, and they're having the same character. The same thing goes for node 4, which is having node 1 as its ancestor with the same character. For the node 2 as well, it has an ancestor which is having the same character. And what we will do now is remove the edges for each and every node which had a parent, which had an ancestor with the same character. We will remove the node for like this, um, for this node 3, which had its closest ancestor as 0 having the same character. We will remove its node with its parent, and then we will add a new node for this node with its closest ancestor having the same character. Similarly, for the other nodes, like the node 2, its closest ancestor was 0. So in this case, even after removing and adding an edge, we will have the same parent. Here as well, we will remove the edge with the parent and add the edge with the new parent, which is the closest ancestor having the same character. So the tree will just look like this. The node 0 having 3 children now, the node 3, the node 1, and the node 2. Then the node 1 will have 2 children, node 4 and node 5. This is the new tree. Now for each and every node, find out the number of children it has in its subtree. Basically not children, but the number of nodes in its subtree. So for the node 0, its subtree is the complete tree. So it has 6 children. For the node 1, it has 3 nodes in its subtree. That is why we have 3 here. And for all the other nodes, these are now the leaf nodes. So they don't have any children. Thus, in their subtrees, these are the only nodes. So we are having 1, 1, 1, 1 everywhere. I hope this dry run of the example made some sense, and the problem should be clear now. So please tell me in chat once, is the problem clear? Or does anybody have any doubt in this problem, at least in the problem statement? Let me take one edge case as well. Not an edge case, but someone might have a doubt like this, that if you are having a node 0 with the character A, it has a children with A, which has maybe a children with B, and it has a children with the character A. So in this case, for this node 3, it has 2 ancestors which are having the same character, right? So we will go on with the one which is closest to this node, which is this one. So this tree will now transform into the node 0 having 1 children as it earlier had, and this will have 2 children, the node 2 and the node 3. Then we just have to raise 3 to 1. Okay, so somebody is saying that he wants another dry run for the example. So let me do it. In this problem, just 1 second. In this example, yeah, so in this example, let's go node by node. First of all, we came to the node 0. It does not even have any ancestor, so obviously it does not have any ancestor having the same character. Let's move on to the node 1. It does not have any ancestor with the same character, any node having the character B. So for node 1 as well, we don't have to do anything. For the node 2, it has an ancestor having the same character. So what we will do is, we will remove an edge and add a new edge. Like, we will change its parent. In this case, the parent is still the same. Then for the node 3, it has the ancestor 0, which is having the same character. So we will change the parent of the node 3 by removing the node 1 from it being a parent and adding an edge between 3 and 0. And then for the node 4 as well, it does have an ancestor having the same character. In this case, it is the same parent. And for the node 5, it does not have any ancestor with the character C. So in this case, the node 3 is now having the node 0 as its parent. For the other nodes, the node 4 and the node 2, their parent is still the same, so the tree does not change there. Their parent is still the same. Now my tree will look like this. Now I will go for each and every node, like for the node 0, and see the number of nodes in its subtree. I have 6 nodes. Then for the node 1, I have 3 nodes in its subtree. Then for node 2, I have 1 node only. Then for node 3, again I have only one node. Then for 4 and 5 also I have only one node in their subtrees. So this is why the answer will be 6 3 1 1 1 1. So is it clear now? Ankit, please reply, and if it is clear, then we can move on to the logic part. Okay, so somebody is saying that please try run the second example as well. So let me look at the second example. In this example, okay, so here we have a tree like this one, and the parent of, like, you can just look at the parents. For 0 it does not have any parent. For 1 and 3 they have 0 as the parent. For the node 4 it is having 1 as the parent, and the node 2 is having 4 as its parent. And for the node 0 it does not have any ancestor with the same character. For node 1 and 3 as well, they don't have any ancestor with the same character. The node 4 has 0 as its parent with the same, no, node 4 is having 0 as its closest ancestor with the same character. So for 4 you will remove the h and add an h like this. And for the node 2, for the node 2, if you look in the current graph, since we have to, like in the problem we have been told that we have to do the same operation simultaneously for each and every node. So at the time when we would check about the parent for the node 2, the ancestor for node 2, one would still be its ancestor. It won't happen like you have removed. We have not really removed the h till now. We will remove it, but currently, first of all, you would just find out the closest node for each and every, closest ancestor for each and every node. So for B, 1 is its closest ancestor having the same node, having the same character. So for 1, in future, what you will do is remove the edge here and add an edge like this. So the new tree will look like, it would look like this: 0 having 3 children, 1, 4, and 3, and 1 will have a children too. So for 0, you are having all the nodes in its subtree, that is 5. For 1, you have 2 nodes. For 3, 2, 3, and 4, you are having one node only. So 1, 1, 1. Is it clear now? Okay, so somebody is asking that is not it big O of n square. We have not really discussed about the way in which we will solve it. Currently, we are just trying to understand the problem. What is the problem demanding us to do? So one thing is very clear. For each and every node, you want to find out its ancestors, like the closest ancestor having the same node. Then deleting the, basically changing the parent wouldn't be a difficult task. It would be an easy task when you have to change the parent for any node. But the difficult bit of this problem would be, for each and every node, you have to find out its closest ancestor with the same character. So we have to focus on that part. Once we are done with it, and we would have created the new tree, then finding out the number of nodes in the subtree is also not difficult. It is also simple. So for now, the difficult part is you have been given a tree. Oops, sorry. The difficult bit for this problem would be that you have been given a tree, and for each and every node, you will have some character associated with it. These characters might be unique, might not be unique. Anything can happen with them. And what you have to do is, for each and every character, you would like to find out its closest ancestor with the same character. So basically, you would like to keep some information related to the ancestors um, kept with you. Like, obviously, since we have been given a tree and we would like to traverse over it, so we would definitely apply either of DFS or BFS. And we must apply this. Now, this is something you can remember for future, that if you ever have a problem related to trees, and for each and every node you need to keep track of some information related to all of its ancestors. Like, for this node, I would like to keep track of this ancestor and this ancestor. Then always go with DFS. Like, most of the times DFS will work better than BFS, because in DFS we are basically just going up like we just go like this. So we always have all the ancestors already stored in the stack for each and every node. So keeping some information related to them would also be easy. So is it making some sense that why are we gonna think about applying DFS on this problem? Yes or no? Does it make some sense? Or at least after listening to the reasoning I gave for thinking about DFS, do you think that it is now gonna look intuitive if you ever get a new problem like this one? So let's just take the problem. Uh, Maybe let's take a tree. You have A, B, A, B, and C. So obviously we will go by DFS. है ना? Now, what do you want to keep track of? For each and every character, you want to know about all of the ancestors who had the same character, or in particular, you want to know about the closest ancestor, or basically the latest ancestor which had the same character. So, in case if the tree looked like this, then when you came to this node, then this node, you would like to know about this node in whatever information you kept for all the ancestors. You would like to know that, hey, there is this node which is having the same character. And this is what you want to do. So this is the place from where you will start to think about what to do in the, like, what to do to solve the problem. So um, I'm just thinking about the way in which I can actually explain this. Okay, I think it would be fine like this. Um, what you can do is, for each and every character, since if this character has A, you want to find out the closest ancestor having the character A. Let's say when you are at this node, since it has the character B, you want to know about the node among the ancestors which is having the character B, and so on. So does it make sense if the information which I was to store for the nodes, if I store it like this, that the list of all the ancestors which had the character A, the list of all the ancestors which had the character B, the list of all the ancestors which had the character C, and so on till Z, the list of all the ancestors which had the character Z. Somebody saying an ordered map. It's not a worry for now which data structure you would use, but let's focus on the logic. That does it make sense? Maybe let me name these nodes. So when like when I go with DFS, first of all I will come to this node. I can just say, I can just check that, hey, I am having the character A in this node, and the data structure, whichever data structure I maintained, which would keep track of all the ancestors which had the same character, is empty. So there is no correct there is no node having the same character. Basically, you have been at this place that there is no node y. The node y does not exist, so we would do nothing, and we will go to the next node. Now, when you go to the next node, you know that you would like to have this node 0 being stored here, so that for the future nodes you would know that the node 0 is an ancestor having the same character a. So you would just push it here, and then you will come up to this node a. You will see that, hey, this is having the character a. I would like to check if there is any ancestor having the same character. You found that, hey, 0 is have there is a node 0. So now what you can do is just say, hey, whatever node which I had the previous parent, I don't really care about it. Maybe I can create a vector of integers with name new parent, and in new parent of 1 I will put up 0. I can do something like this in order to know which node should be the new parent. uh, yeah, and then I will go to the next node. Let's say I came here again. Whenever I'm going to the next node, I would like to store the information of the current node in the map or whatever data structure I am maintaining here. Let's say that I'm maintaining a map for now. So in the map, I will just say A has come on the nodes 0 and 1. When I reached here, I saw that 1 is the latest node. Let's say that this is a vector of integers. So whatever node was being pushed later on, whatever you have as the closer ancestor would be here and on the right hand side. So you saw that a, like this 1 is the closer ancestor. So again you will just remove this edge and add a new edge with 1 itself. Then you will, since you are not going up any deep, but just to keep consistency, as you were adding the information of the current node in this map, you would add the information of the current node, that is 3, in the map as well. And then you would like to go, since you don't have any children, you would like to go back to its parent. Whenever you are going back to its parent and that parent will go to some other branch, for that node you won't be an ancestor. You are not going to be an ancestor for that node. You will be ancestor for only those nodes which are coming up in your subtree, है ना? So it makes sense that this node 3 would not be an ancestor anymore. So we can just say that whenever you are going back to a parent node, you will remove the current node from the map. Then you went to the child node and you saw the character b. So you just said that, hey, for the character b, the node 4 is coming up, and then you will see that you are going back to the node 1. So you will remove it from here as well. Then you will go here, you will add 5 here, then you will go back, so you will remove it. You would have reached here. The map will look like this, right? After that, you have already traversed all the children now. So you would like to go back to the parent. You would like to go back to the parent, that is the node 0. So whenever you are going back to the parent, you would like to remove the current node. It makes sense. So the map would look like this, and then you would go to this child, and I hope you got it. Probably you got the logic that as whenever you call, like whenever you go deeper into the tree, you can just add the current node in the map so that all the children will know that, hey, this node, like there was a node 0 which was having the character a. And similarly for each and every node, whenever you go deeper, you will just add that node in the map. And whenever you go to the parent, you know that now the next all the nodes which you will traverse, for them the current node won't be an ancestor anymore. So you will just pop it out from the map. So does it make sense, guys? Yes or no? Did this dry run help? Okay, so one person said yes. What about others? If you have any doubt, then please ask. And if it is clear, then please mention so that we can move on to the next problem. Basically, move on to the code and then the next problem. Okay, so If nobody is having any doubt, then let's move on to the code. In the code, as I had said earlier, first of all, we want to find out the ancestors for each and every node. है ना? So we can do it like this. We can just run up a DFS function. Now the code which I have written here might look a bit different. Generally, we people create functions like this, void DFS and something something, int node, int parent, and so on. But instead of that, I have created a lambda function. The reason behind creating a lambda function is that you don't have to pass on all the parameters. Like I don't have to pass on this map which we were creating as a parameter. Neither I have to pass on the adjacency list in the parameters list. So it just makes the code a bit shorter, so you can write it a little bit faster. That's why I have written it like this. If you are not comfortable with it, then feel free to write it like this. Okay. So in the DFS function, the main thing which I'm doing is this bunch of code first of all checks if there is any node which is having the same character, if there is any ancestor which is having the same character, and if there is any character having the same ancestor, then I'm just updating the parent. Yeah, by the way, before running the DFS function, we had created an adjacency list here. So since adjacency list has been created, now I don't really have anything to do with the parent array. So I'm modifying the parent array which I was being given in the parameters. So I'm checking if there is any ancestor having the same character. If there is any ancestor having the same character, then I'm updating the parent to that ancestor. Then I'm adding the current node in that map. So the syntax in which I have written might look a bit confusing to some people. So you might like to see it like this. Basically, I didn't want to write this thing again and again. So I just wrote it like this so that instead of writing this everywhere, I can just write back. So I'm adding the current node into the map, and then I'm going to the children. Once I would have traversed the complete subtree, I will come back. So I will just pop out the node there, and I'm calling that DFS function now. After that, since my parent array has been modified, now I can use that new parent array, the modified parent array, for creating the adjacency list once again from scratch. So I'm doing it again. And after that, now I just want to iterate over this given tree once to find out the number of nodes in subtrees for each and every array. So you see, the number of nodes which would come up in the subtree for the node 0 would be nothing but this current node. Like this is one node, all the nodes which are coming up in the subtree for the child 1, and all the nodes which are coming up in the subtree of child 2. So I can just say that for any node, like if there is a node u having children c1, c2, c3, then the answer for the node u would be nothing but 1 plus answer of c1 plus answer of c2 plus answer of c3. That's it. So we can just run up another DFS for that. And in the DFS, I'm doing nothing but this thing only. Initialized answer of u with 1. And for each and every child, I'm incrementing answer of v to answer of u, where v is the child of u. And at last, I'm returning this answer vector. Okay, so somebody is asking how are we keeping track of the closest ancestor? Um, are you asking about that in the code part or in the logic part? If you are asking for the logic part, if you remember, we had maintained a map where for each and every character we were having a list of all the nodes which came in the ancestor, like which came as ancestor for the current node and had the same character. So whichever node came first in a path from the root till the current node would have come first in the vector, then the new node, then the next node, and so on. है ना? So whichever node you see at the right hand side, basically at the end of the vector, would be your closest ancestor having the same character. So this part here is getting the list of all the nodes, all the ancestors with the same character, and then this part is getting the closest ancestor by looking at the end of the list. So Musaddiq, is it clear now, or do I need to explain some other part as well? Just in case if I was not able to explain the exact doubt which you were asking, then please mention. Okay, got it. Great. We are adding up to vector bag in general. Yep. Okay, so let's move on to the third problem. I think third is simpler than C. In the third, oh, just one thing. Okay, so this is the second problem in which we talk about the time complexity and space complexity. So the number of nodes are n, and the number of edges would be n minus 1 since this is a tree. So this adjacency list will have only big O of n time complexity and space complexity. So for the part of time complexity, this will take big O of n, and then this DFS will also take only big O of n. This will also take big O of n. This will also take big O of n. So overall, we are having only big O of n time complexity in general. And for space as well, we are having only big O of n as this array, this thing, and this thing. These are the only things which we have created. So in general, you can say that the space and time complexity are big O of n. Okay, let me look at the chart once. Musaddiq, yeah, what you are saying is correct. Okay, so let's move on to the third problem. The problem says maximum points tourist can earn. In this problem, we have been given two 2D integer arrays, stay score and travel score. A tourist is visiting a country with n cities where each city is directly connected to every other city. The tourist's journey consists of k0 indexed days. They can choose any city as their starting point. And each day the tourist has two choices: either stay in the same city, where in this case the score tourist will get is gonna be stay score I kar, where I is the day, basically on the day I, and since the city is kar, so stay I kar. And if he moves on to some other city, then the score he will get is equal to travel score kar to dest. We have to return the maximum possible points that tourist can earn. So this is the goal which we have to find out. Let me take one example. Oh, sorry. So if you have, yeah, there are two cities. Huh? There are two cities, city 0 and city 1. And there will be k equal to 1. So there will be 2 days, k equal to 0 and k equal to 1. We have zero based indexing for days, so we will have the day 0 and day 1. So let's say the tourist started from the city 0 on day 1. Like on day 0, let's say tourist is on the city 0. He's here. So right now he's having two choices: either stay here itself or move on to the city 1. You know? So if he stays at the current city, in that case, on day 0, on day 0, for staying up here, um, oh wait, are the days from 0 to k minus 1? I think the days are from 0 to k minus 1. So here we will have only day 0, not day 0 and day 1. So on day 0, if tourist had started here and let's say he stayed at the same place, then in that case, he will get stay score of 0 because this is the day 0 and 0 because he's in the city 0. So this 0 comma 0 is 2. So sorry, yeah, this 2. So in that case, the score this tourist will get is gonna be equal to 2. On the other hand, if he had decided to move on from here to here, in that case, he would have earned travel score from city 0 till to city 1, which is travel score 0 1, that is 2. So he would have again had a score of 2 in that case as well. If he had started in city 1, let's say if he had started in city 1, then on day 0 he would have earned stay score of 0 because this is the day 0 and 1 because this is the city 1. Like in the first place you have the day number and in the second place you have the city. So stay score 0 1 is actually equal to 3. So in that case, the tourist could have a score of 3, and the other possibility is he was at 1 and went to 2. In that case, he earned travel score of 1 comma 0 1 0, which is this 1, which is a very bad score. So basically the best score he can get is 3. So I think we have mentioned he can earn the maximum score by starting at city 1 and staying in that city itself. So I was just showing you a bit of dry run so that the problem should be clear on of what we have to do. Now, if you look at the constraints, they are very small, and the total number of cities can only be 200. The number of days would also be at most 100, and uh, these variables are regarding the score you can get. And basically, the main thing is you're having the days from 0 till k minus 1, which is at most 200. You know, 200 distinct possible days. Nextly, the number of cities you have is also from 0 till n minus 1, where n would be less than equal to 200. Here k was also less than equal to 200. And let's say on the day I, you are in city C, then how many choices do you have? You have n choices. Actually, n plus 1 choices, out of which one of the choices is just useless. So these n plus 1 choices are, you can either go to city 0 or city 1 or city 2 and so on till city n minus 1, or you can say that hey, I will decide to stay in the same city. So basically you have already considered it as well now, ki among those n cities, if you are deciding to stay in the same city, actually you can just consider it as n choices itself. Here having n choices, from the current city C, you will either go to city 1, city 0 or city 1 or city 2 and so on till city n minus 1. In case among these cities, if you have decided to go to the same city, then you will get the score stay Yeah, you will get the score stay score IAC. Otherwise, you will get the score if the city where you are going is V. Then you will get the score travel score CV. Right. Let me explain it again. So basically, what I said is, let us say I days have passed and you are in the city U. Now, from the city U, on the day I, either you can remain in the same city or you can move on to the city 0 or 1 or 2 or 3 and so on till city n minus 1. Hana, you are having only these n choices. If you had chosen to go to the same city, in that case, you will get the score stay score of IU. If you move on to some other city, then you will just get travel score U to V, where this V is the new city where you are going. Hana? So how many variables do you have here? You are having one variable. How many days have passed? Another variable in which city you are right now, and the other variable in which city you will go. There are k possibilities for the city in which you, sorry, the number of days which have passed, or which day we are talking about. For the city in which you are right now, there are n possibilities, and the city where you want to go, there are n possibilities. From there, you could have got the intuition that, hey, even if I just brute force the thing, that for each and every day, I consider each and every city as the possibility that I might be, the traveler might be at that place, the tourist might be at that place, and then you consider all the choices he has, you will have this time complexity because of k into n into n. You know? And all of these are less than equal to 200, so it is like 200 raised to the power 3, which is nothing but 2 into 10 raised to the power 2 raised to the power 3. So it is 8 into 10 raised to the power 6. Even less than 1 is 7. Right. So this is how you could have got the intuition that even if you just try to think about the brute force, it will work. Now, some people might be able to relate it with dynamic programming. If you have done dynamic programming, then for sure this problem will look simple. You can relate with it. But even if you don't know about dynamic programming, I believe the problem is still very doable. All you need to do is just consider that if it was the day I and you were on the city U, and let's say you had earned score of U, like your current score was, let's say, score of U, the maximum score you would have got till now for reaching the city I after I days, sorry, reaching the city U after I days, and you are about to move to the city V, then let's say new score for V would now be equal to the maximum of um, it would be the maximum of all the possible ways from where you could have reached there. Basically, you could have reached this city V from U, or you could have reached from 0, or you could have reached from 1, or you could have reached from n minus 1 as well. You could have reached from any one of them. So uh, the new score for V would be equal to the maximum of score U plus uh, the travel score from U to V. है either the travel score or the staying score. So let me write it here with more space. So new score of V would be nothing but maximum of score of U plus travel score from U to V. or the maximum of this and the maximum of um, score of V plus stay score of IV, right? If on the ith day you were at some node and now you are coming to the current, you are coming up to the node V on the day I plus 1, then the maximum possible score for reaching the node reaching the node V after I plus 1 days is nothing but the maximum of all of these transitions from where you could have reached to this current node. And there will be all these nodes and the node V where you would have just decided to stay at the same place. So yeah, I think at this place it might be looking a lot more like DP. But the reason I'm not trying to explain the same way as we explain the DP problems is because I think even if somebody does not know about DP, it is still solvable. Okay, so let me look at chat for now. And please tell me if you're with me right now or I have explained something badly. Just please tell me that if you have lost somewhere, if you have some doubt. Otherwise, we can move on. Okay, so somebody is saying that he's able to relate it more with graphs because you are having a tourist who's visiting cities. So yeah, you can relate it with graph as well. Basically, DP and graph are the same thing now. In DP, um, in DP you say you have states and transitions, and you can just visualize the same thing as graphs where these states would be nothing but nodes and the transition from one state to another state would be nothing but an edge between two nodes. So it's up to you. Oh, Garish Paliga in the chat. Nice. By the way, guys, does anybody have any doubt till now? Can I just say that if I knew the answer till the node I could easily move on to the node. Sorry, if I had the answer till the day I for each and every node, then I could find out the answer for each and every node for the day I plus 1. So what I can do is I can go from the day 0 and just have multiple iterations until I reach the day k minus 1. And on day k minus 1, for each and every node, I would have found the best possible scores to reach that node. So the maximum one of them would be my answer. That's it. New relation V. Can you explain it? Okay, so this relation is just, I said that if on the day I plus 1, I want to reach to the node V, then there are multiple cities from where you could have reached to this city. You could have reached this city from the city 0 or 1 or 2 or U or maybe even n minus 1 or maybe even the node V. है ना? So if you reach this city from either of these, in that case, the score you would have got while reaching to this node, the new score for the node V would be the score you had till this place, these places, that is nothing but score of V, score of U, plus the travel score you got. है ना? Whenever you travel from some node to some other node, you get the travel score UV. So either you can get this as the new score, whichever one is the maximum one, or the other possibility was you could have been on the city V on the ith day and you might have just considered to stay at the same city. So in that case as well, you can reach the city V on the I plus 1th day. So this will be the score in that case. Score the best score for reaching the city I, sorry, city V on the day I, and staying there. So when you stay there, you will get stay score of I comma V. So does it make sense now? So if you know about DP, I think it would be easier to relate. But now let's talk about the way in which I did it. It was similar but a little different. I just considered that if I am at node U after I days and I move on to some other node, then I will reach the node. Let's say I call this as the node V. I'm going from node U to node V. Then I just said that the score, yeah, one more thing. Instead of declaring this 1D array of score, I declared a 2D array score. I named as score IV, score I U maybe. Score of IU denotes to the max score I can get when I reach on node U on day I. Right. So in that case, if I'm going from node U to node V, then score of I plus 1V should be equal to the maximum of score of I plus 1V and the score of IU plus travel score UV. Does it make sense? Guys, does it make sense? Yes or no? Yeah, I can loop from 0 to -1. Um, Guys, please reply in chat. So, if in case if anybody is having any doubt, then feel free to ask it. Equation. The equation is stating nothing but if you are going from node U to node V, then the score for the node V on the day I plus 1, because currently on the day I you are at the node U, and if you travel on the current day to the node V, then you would reach the node V on the day I plus 1. So that is why score of I plus 1V, this will be the state which would be changed, and it will become nothing but equal to the maximum of its current value right now, whatever is the current best score you can get for reaching to that node on the day I plus 1. And this thing, which is nothing but the best score to reach to the node U, and then traveling, the score you get while traveling from U to V, that being added. So, Trithiraj, does it make sense now? Yes or no? Um, maybe I can give a recap for the problem. So in the problem, we had a tourist who would travel from some city. There are n cities in a town. No, sorry. There are n cities in a country, and the tourist will move on from cities to cities, or maybe stay at some city someday. He will be there for k days. So we are being told that if there is a tourist traveling from city U to city V on day I, in that case, he will get travel score of UV. He would be rewarded this many points. Or if he is staying from like in that city itself, he's not moving to any other city. In that case, he will get stay score of U to U. Fine. So we have to find out the maximum possible score that tourist can get when he is allowed to start from any city and he can end up at any other city, any city of his choice. So since the problem asked us to find out the maximum possible points we can receive, it is related to finding maximum for something where at every point you are having multiple choices, you know. So it does remind us of doing something like finding all possible combinations, finding out all possible combinations. Basically, just try out all the possible combinations. That what if the tourists start from here and go on to that city and so on. You know? So this thing reminds us of two things. Maybe brute force. Basically, brute force. We are just talking about the brute force here only. That we will try out all the possible combinations, which can be further optimized with DP. Now, earlier I was just trying to think, uh, trying to tell you in a brute force manner that if somebody has not studied about DP, he might still be able to solve the problem. So um, I don't think the response is looking good. So let's try to just straight away go to the DP stuff. We will try to think about the problem with the DP mindset. You would like to have some states and some transitions. You know, find out the base case and the result at the end. So for the part of base case, we will start with the state part. So if you just know that on the day I, that tourist, if he ends up on the state U, he is having score IU. The best possible score he can receive is score IU. Then can I say that this is enough? You don't really care that whether the tourist went from city 0 to 1 to 5, then to 7, then to 2. Let's say this was how the tourist had gone. You don't really care about it. You only care about the fact that in 5 days he reached the state 2 with, let's say, 10 points. 10 points. Huh. So we can very well say that the state would be score of IU, where today is the day I, or you can say that I days have passed. Either one of them is fine, 0 based indexing or 1 based indexing, and use the current city. Now for the transition part, either you will go from same city, and basically either you will stay in the same city. In that case, score of I plus 1 U should be equal to score of IU plus the stay score for U on the ith day, that is stay score IU. Or if you travel from city U to V, then in that case your score of I plus 1 V would be equal to score of IU plus travel UV, right? These are the simple transitions. What will be the base case? It's simple. For score of IU, it would be equal to 0 for each U. है ना? Because initially on the day 0, at the beginning of day 0, you don't have any points. So score of everything would be 0 initially. And the result is gonna be maximum of score. Okay, this was 0U. Okay, so the maximum of score K, like for, or you can just say it as max of score K U for any possible value of U. So now did you understand what we can do for solving the problem? Guys, at least say no in case if you didn't understand. Right now I'm confused whether you didn't understand or is there nobody in the live stream right now? Yes, I get it. For the current transition, we are using the past answer like this. Okay, understood. Okay, so let's move on. Then, okay, U2V transition repeat. See, if you are in the city U and you know the best possible way for reaching to the city U in I days so that you get the maximum possible score you can get, and you are moving from this city to some city V, then obviously you will reach there on the day I plus 1. You know, if you travel from day 0 to some city to some other city, then you will reach there on the next day. That's according to the problem. Now it means that score of I plus 1b according to our state, where we are just considering the best possible score for reaching some city U on day I, was score of IU. So for like the best possible score for reaching the city V on day I plus 1 would be score of I plus 1v. And it should be equal to the score which you had already achieved till now. Let's say while uh, let's say I traveled for 10 days and I reached the city 5. While reaching the city 5 in 10 days, I earned 1000 rupees. And while traveling from U to V, you will get travel of UV. है ना? Let's say while traveling from U to V, earlier you had 1000 rupees and you got 50 extra rupees. So now you would have got 1050 rupees. है ना? So this is what you have got. This is what you have got if you come to this state from U. This is the best you can get. है ना? But it doesn't mean that this is going to be the best possible way for reaching the current city. There is a possibility that this city, let's say you are coming from city 5 to city 7, but if you had come from city 10, maybe you could have earned more while reaching the city 10 from some other way. Let's say you were earning 900 rupees and travel score of 10-7 might have been something like maybe 200, let's say. So you could have earned 200 more and you could have got 1100 rupees while coming till this point. So for the Note 7, you would like to consider whatever is the maximum score you can reach, whatever is the maximum score you can get while reaching here. Yeah, we are trying out all the possible combinations, all the possible ways. And whenever we have to try out all possible ways, we generally, for the brute force way, we generally either use recursion or backtracking sometimes we can just have our brute force way iteratively as well, and then we can optimize that using DP. So in this problem, whatever DP states we form, this is actually very similar to the way in, like the brute force way in which a person will think. Or I might be wrong about this. Sorry if I'm wrong about it. Like I felt that this might, the brute force way might already look intuitive, but in case if it then look intuitive, then sorry about it. I hope that the DP solution is clear, at least the DP mindset. So in the code, first of all, we have created the states. Then we are having uh, these, yeah, we are having these two for loops for basically having all the transitions. We are having, sorry, we are having these states, and then we are having these two for loops for going on to each and every state. Like this was our state, score of IU. So we are having these two for loops I and U for reaching every state. Then for the part of transition, for a node U, you will go to each and every node V from 0 to n minus 1. So we are going up from each node from 0 to n minus 1. Then thus node V would either be different from U or it would be equal to U. So if it is equal to U, then you will be getting this stay IU wala amount. Otherwise, you will get this thing. So I just created a variable with name current in which the value will depend upon whether U is equal to V or not. And then we are having this transition that you are reaching the node V on I plus 1th day. So the new best score for reaching there would be either the previous maximum, either the previous best, or the new transition. Basically, whatever best you could get for reaching the node U, and the extra amount you get for traveling from the node U to node V. And at the end of the day, the answer is the maximum of all the possible, uh, like for all the possible ending cities. Like on the kth day, you might have ended up on city 0 or 1 or 2 or 3 or till n minus 1. You know? So let's say for the way in which you end up at the city 0, you are getting 1,000 rupees left. Let's say for city 3, it is 1,050. For city n minus 1, it is, let's say, 1,200. So whatever is the maximum one of them would be our answer. Yeah, we can either travel to another city or stay in the same city. So the time complexity here would be, we are having a for loop of n k size, then two for loops of n size. So it is k into n, and all this is a big O of one time. So this is gonna take big O of k into n time, and then this line will take big O of n time in itself, and this line will take big O of k into n time. So overall time complexity will be big O of k into n, and the space complexity will be big O of k into n, the space which we declared here. Okay, so guys, does anybody have any doubt related to this problem? Can we optimize more? Um, I didn't try to think about it actually. Um, I don't know if we can optimize it anymore. At least I can't think of any way right now. Even small optimizations. If constraints get tight, then what to do? Here the problem setter will set up the constraints after thinking about the solution. Now if the solution, like if he has some solution in mind only, then he will make the constraints, right? He won't give you uh, n being as large as 2000 here unless there is some possible solution and some easy one, since it is the C problem. Any other doubt? Okay, so if nobody has any doubt, then I think we can end the stream. Thank you for watching and bye bye.